Hello and welcome to my YouTube channel. In this video, I am going to explain how to draw shear force and bending moment diagram of an overhanging beam with 3-point loads acting downwards. As you can see in a diagram, we have 2 kN, 3 kN and 4 kN. Okay, let's follow the steps as we follow normally: reactions, shear force diagram and bending moment diagram. First of all, we will calculate reactions. So reaction will start from, this is RA and this is RB. Okay, so RB multiplied by 2 is equal to 2 multiplied by 1 plus 3 multiplied by 3 plus 4 multiplied by 4. Okay, 2 plus 9 plus 16, 27, and then RB is equal to 27 divided by 2 is equal to 13.5 kilonewton. This is at RB. To calculate reaction at RA, RA is equal to total load minus RB. Okay, so total load we have 9 kilonewton. So 4 plus 3 plus 2 is 9 minus 13.5 kilonewton is equal to minus 4.5 kilonewton. So this is at RA. So at RB we have 13.5 kilonewton, and at at RA we have minus 4.5 kilonewton. At RB we have 13.5 kilonewton. Okay, so based on these numbers we can draw shear force diagram. So at RA minus 4.5, so we will come down minus 4.5. Okay, then we will move to point C with a straight line. Then we will go down 2 kilonewton, it will be minus 6.5 kilonewton, 4.5 plus 2 obviously going down, so it will be 6 kilonewton, 6.5 kilonewton. We will go to point B. At point B we have 13.5, so we will go up by 6 and then again we will go up by 7 kilonewton. Okay, then we have to move to point D. D is acting downward at 3 kilonewton. Okay, so this is 3 kilonewton. Once you are at point D, then we have to move to point E. At point E is 4 kilonewton acting downward, so this is 4 kilonewton acting downward. So this is our positive zone and this is our negative zone. Okay, so that's how you can draw a shear force diagram for this type of beam. Now we have to draw a bending moment diagram. Before doing a bending moment diagram, we have to calculate bending moments at each point. So bending moment at point A will be minus 4.5 multiplied by 0 because we have no arm, so that's why it will be 0. Bending moment at point C, okay, so it will be minus 4.5 multiplied by 1 because 4.5 will be minus 4.5 and this is 13.5. 4.5 multiplied by its arm, which is 1 meter, so it will be minus 4.5 kilonewton. Okay, bending moment at point B, so it will be minus 4.5 multiplied by 2 minus 2 multiplied by 1, so it will be minus 4.5 multiplied by 2 and then 2 multiplied by 1. This is the arm length, so it will be total equals to minus 11. And then we have bending moment at point D. Okay, so D is here, so minus 4.5 multiplied by 3 minus 2 multiplied by 2 plus 13.5 multiplied by 1. So minus 4.5 multiplied by 3, distance is 3, 2.2 kilonewton multiplied by 2, the distance is 2 kilonewton, 2 meters is minus because 2 is acting downwards. and then we have RB, which is 13.5 acting upwards, which is plus 13.1 to get to point D. So at point D we will get minus 4 kilonewton. Now bending moment at point E, this is the last point. If we get a 0 kilonewton at this point, then it means our calculation is correct. We can draw a bending moment diagram based on these numbers. So let's do it. It's minus 4.5 multiplied by 4 minus 2 multiplied by 3 plus 13.5 multiplied by 2 minus 3 multiplied by 1, then we have minus again 4 multiplied by 0. This 4 is the last one at point E. It doesn't have any distance, doesn't have any arm, so that's why it'll be 4 multiplied by 0. So what we will get, it'll be minus 18 minus 6 minus 3 plus 27. So at the end we will get 0. So this is a check basically at point A and at point D. I mean last end we have zeros. Now based on these numbers we can draw our bending moment diagram. Okay, so at point A is 0, so we don't have to do anything. At point C is minus 4.5, so minus 4 point is here roughly, minus 4.5. At point B we have minus 11, so minus 11 is somewhere here. At point D we have minus 4, so minus 4 is somewhere here. And then we have 0 at point D is 0, obviously it's here. Now we have to connect these points. So A to C is diagonal line again, and then again C to B is again diagonal lines, B to D is again diagonal line, and the finally is also a diagonal line. So this is in negative zone. So that's how you can draw a bending moment diagram for this type of beam. That's it for today. Thank you for watching my video. Please don't forget to subscribe my channel.